Good morning, everyone. It's Francis. It's 10:58 a.m. Central Time. This is a new whiteboard from ThePerfectMinds. I'm going to cover some of these things. 3 comets, where they are today. YU-55. Going to do a short whiteboard on it specifically. So we got comets Elenin, comets Honda, and Comet Levy. Those are my key interests. Asteroid 2005 YU-55. I know I wrote that wrong. Well, not wrong, I wrote it weird, but I'm not going to worry about my writing. And telescopes, and specifically about telescopes are cosmic obsession, observatory, opinions. Well, I bring that up because, recently I've had an opinion about Dutch's videos of space, the one of Jupiter and the one of Comet Elenin, and so we're going to talk about that because I want to make sure that you all know where I'm coming from, and where if he's watching, he'll get a chance to know where I'm coming from. So today's July 5th, 2011. I'm going to talk about comets Elenin, Honda, and Levy and where they are today. Asteroid 2005 YU-55 and where it is today and where it's going. The telescopes, the Cosmic Obsession Observatory, and why this is hard to do. And then opinions. I want everyone to know that the paper that I write on is rolled up and saved for future presentations. It is, in my opinion, art, much like some of the paintings I do, so they will be sticking around. C-2010X1 Comet Elenin today is 1.46 AU from Earth. Okay, I looked on the calculator. 1.5 astronomical units is, so I rounded this up. I rounded up .5 AU, and that is 139,433,831 miles from Earth. and today it is also 0.964 AU from the Sun. That means it's inside Earth's orbit. What else do I have on that? Basically, that's where we're at with Elenin for right now, is that Comet Elenin today is 1.46 AU from Earth. I rounded up to 1.5, and that's 139,433,831 miles from Earth. Comet Elenin today is 0.964 AU from the Sun. 1 AU is 92.955, 93 million miles, so 93 million miles, so we're probably in the 80 million miles, but you'd have to check on that. That's the right number, I just haven't converted it. The next comet is Honda. (45P) / Honda Merkos Pojdusakova. I can almost remember how to spell it better than I know how to say it. 45P Honda Merkos Pojdusakova, Comet Honda, is 0.16 AU from Earth. 45P Honda Merkos Pojdusakova is the closest comet to Earth. I did on my last whiteboard an explanation of where Comet Honda is flying under Earth. Its closest path, I think, is August 15th, 0815. So it's coming up here pretty close, and it does make a very close pass. Let me see if I have it open. Let me see what I can do here 1 second, and I'll tell you exactly what the closest pass is for Comet Honda and when it's going to happen. I have JPL open. I'm putting in the name. I need to open up the orbit diagram. And I need to move forward. It goes 0.16. It goes 0.16. Tomorrow it's 0.14. And it keeps getting less. Okay, there it is. 0.0603. 0.0603. Its closest pass is on August 15th, 08/15/2011, and the closest pass is 0.0603, and I know that by now is because of my mistake I made on the last one. That is 5.6 million miles from Earth on August 15th, the closest that 45P Honda Merkos Pojdusakova comes to Earth on August 15, 2011 is 0.603 is the closest, and that equals 5.6 million miles from Earth. So it's close right now. It's 0.16. So that's, I mean, whatever, 50 million miles maybe right now, but I'm not going to even do that math anymore. So right now, that's where we're at. Comet Astronomy, Honda, and make sure in my picture that you can see everything. I know this seems to be going a little different and the writing's a little bit smaller. I'm going to keep going, I guess. Comet Levy is the farthest one away right now. Its closest path doesn't happen until 2012, but we're keeping an update on it because it's going to be the next one coming through, and that is P2006 T1 Levy, and these are all comets, 1, 2, 3 comets. Today it's 1.09, almost 2 distances of the sun. And then it's 0.807 from the sun. And again, I've done some other whiteboards with this information where they are in the sky. You just kind of have to go back. Okay, so we did a report on 3 comets. Comet Astronomy today is 1.46 from the Earth. Comet Honda is 1.46 AU from the Earth. Comet Honda is 0.16 from the Earth. And Levy today is 1.09 from the Earth. I'll let that sit up there for a second. And then we'll pull it. This is going to be 2005 YU-55. It doesn't have a name. It's an asteroid. Go back now because I need to get the exact date. Pull it up here, pull up the orbit diagram, and we'll get to the important date. What's the number I have? Let's get in here. November 11th. This is, this is the 11/9. The closest it comes to Earth, this asteroid, is 11/09/11. And it passes at 0.0023 AU. Okay. And I have that figured out as 213,798.542 miles from Earth. So 2005 YU-55 is an asteroid. Its closest pass is on November 9th, 2012. 2011. Its closest path and distance is 0.0023 AU from Earth, and that distance converts to 213,000 miles, 213,798.542 miles from Earth. You might wonder, how far away is the moon from Earth? On average, it is 238,855 miles away. Okay, so that's that news. That's that information, and that is correct. Asteroid 2005, YU-55, passes closest to Earth on November 9th, 2011. It passes 0.0023 AU away, and that is 213,000 miles, 798.542 from Earth. How far away is the moon from Earth? That's a good question. On average, it's 238,855 miles away. So, someone can technically say that this asteroid is closer to Earth than it is the moon on that date. But I'm gonna try to show you something in the next set of images. When they say it's going to come within Earth and the moon, I suppose it's in how you look at it. Here we go. I don't know how I'm going to do this. I guess I'm going to try to split it down the middle and do a split screen. I'm going to go look and see how split we are. I see it. So maybe we'll just try to do this too. And we'll put something in the middle here. First one I'm going to make, I'm going to attempt to make, that's the sun. Mercury, Venus, Earth, and Mars. Okay, so that's the sun. And we're going to go ahead and do this. And 1 equals each line. 1 line, 2 line, 3 line, 4 line. So you can look. You say, well, which one is what? 1 line, 2 line, 3 line, 4 line. And this is going to be Mercury. This is going to be Venus. This is going to be Earth. And here's what I'm going to try to do. That's not great, but whatever. So this weird one here we'll know as YU-55. Let me go back to today now, make sure that I get, because I know the planets are in the right place, I just want to get. Yeah. I'm over here. Okay, what's important to note, and I'm going to try to do this, I did this on another one, is that I'm going to add some dashed lines. These dashed lines, oh, it's going to be hard, but we're just going to try to go with it. The dashed lines are when this asteroid is above the sun's equator. Okay? And this single line is when it is below the equator. Okay. This point right here is the date of November 11th. November 9th. This is where Earth, 1, 2, 3, is going to meet up with the orbit of YU-55. These dotted lines represent when YU-55 is above the sun's equator and the Earth's equator. This solid line represents in the orbit when YU-55 is below Earth's equator. So sometimes it goes below it, and then as it's on the other side of its orbit, it's higher than the Earth, and then as it gets closer in this instance, it's mostly near it. But November 2nd, a week before, November 2nd and 3rd here is when it breaks the ecliptic plane and it starts moving up. So somewhere between here and when it actually gets to here, it is actually level with Earth. So at this point, 11-2, the asteroid is on our plane. We could look out on the horizon and see it. So we have a week of movement, and I don't know what the momentum is, how much it travels, how fast it's going, but it'll have a week of movement to basically sail over Earth. And this is where we're going to get to this next drawing. And we're going to just try to do it like we always do it. I've been wanting to improve the where the equator goes on my Earths. So please forgive me. I mean, you know how this goes. And I'm not even, well, I know that it's, and then there. I hope you can recognize that. That's Earth. I hope you can recognize this, and that's the sun. And we're going to do, I'm going to do an odd, well, I don't know. This is basically, this is what I'm going to do. Because I have to put in the orbital path of YU-55, and we're just going to do it like this. So, and this is what the simulators have shown me through my research. It doesn't show as drastic as this. It appears that, you know, it's traveling level, more level, but, you know, we have a week of travel, so, you know, the goal is to get it up. The orbital path takes it above Earth. So this is what we're talking about. Let's just say, and I don't even know what YU-55 looks like. Okay. Okay. And then we're just going to try to go with this. And this date is on November 9th, 2011. This distance is 213,000 miles. Okay, this is important now because we have to get the moon in here, and the moon is above, rides above the equator. I don't know if y'all are going to accept this, but let's put the moon right here. Okay. That's the moon. Now, and that looks silly. I never did a moon before, so let's just Do like that. And so the moon from the Earth is on average 238,000 miles away. And in this instance, it's on the other side of Earth from our viewpoint. Away, it's pointing away from the United States and everything over here. For us, it's night. For the other side of the world, it's daytime, and the moon is up during daytime, and it's a full moon. And it is on. I do not know the moon's position. I will look into it. If somebody says, well, that's not where the position of the moon is going to be, I want you to know that the moon will may be somewhere else, but it's going to be on this plane. It's going to be on the plane going around. And so at this point, 11.9 is passing, the models say that YU-55 passes above the Earth. And that should be where the moon isn't. So technically it won't be flying in between the Earth and the moon. It'll be flying over the Earth and the moon, basically giving the Earth a second moon. This diagram probably needs to be refined more. And I need to go ahead and say that because what I need to know in this instance, and you're probably going to recognize this, and I'm just going to draw it quickly, and this is just what I'm thinking as I'm doing this, and we're just going to, okay, and I did that wrong, this is the wrong line. I need to find the right angle of the Earth. I need to find the right, what is the representation of the equator of Earth? Is it like this? Is it like this? Because now how does the moon rotate? Does it rotate like this? Or is it always like this? This is some of the answers I'm going to have to find out for you. And this is why I'm working in it with my head, because now if it rotates like this, and the order path is up here, but I still don't think there's any way for the moon, because the moon doesn't come above. I mean, if they show that the asteroid is flying above Earth, the moon doesn't come above Earth. But maybe in this scenario we're talking about more level with the top of Earth. I don't know if you all understand me. It depends on the degree. And see, I can draw an Earth with a flat equator. And that might not be doing us as much good. So we're going to go further before November 9th, 2011. We're going to go further with YU-55. And even on my other videos, we're going to refine Earth. I'm going to start drawing Earth as it should look. Whether it has the equator like this, or this. So, look forward to that. I will refine this whiteboard later. But the gist of it is, YU-55 has a week to come from wherever the equator is, 1 week to get from the equator up above Earth and the moon. It does get closer to Earth than the moon is, but to my understanding, when people say it was going to fly in between the Earth and the moon, it cannot, because the Earth is, the moon is not high enough up here for this thing to fly in between it. It will come within Earth. The Earth will have two moons in that effect, but it's not flying in between the Earth and the moon. And we hope that it just does what it's supposed to do up here, its path, and flies above Earth on 11.9. On 11.2, it goes from under the ecliptic plane to up. So on 11.2, it's level with Earth. It's somewhere right level with us, and it has a week to travel from level to above. I hope that none of this made this discussion irrelevant, but look forward to me having a refined Earth so that I can start putting in the equator correctly, because that is a goal. Alright, telescopes. A telescope. A telescope can be mobile or permanent. I'm trying to find the right words. Permanent. A telescope can be mobile or permanent. A mobile telescope is like what we have at the Cosmic Observatory. Why is it mobile? Because you have to set up the telescope every time you view. A permanent observatory, the telescope gets set up once and it's there. And it's ready for the next time, and it's ready for the next time. There's a lot of setup involved, I'm going to go into that, to get a telescope to do anything relevant. And, you know, it's different. In order to get a telescope to help you find stuff, you have to set it up correctly. In a permanent observatory, the telescope is never torn down and it's always ready. And an observatory like at Cosmic Observatory, which is my mother-in-law and my father-in-law, Bob and Debbie's equipment, we have to set the telescope up every time, and Bob is going to build a permanent dome for the telescope, but we don't have that yet. And what does that mean? Mobile, permanent? Basically what it means is how long it takes to start seeing. And in the case of Comet Astronomy, we're at a disadvantage because we're short with time. You have to wait to a certain amount of time so that the telescope can start seeing stars in an almost daylight sky. But from the time the telescope can start seeing stars in that sky, even though you can't see them with your naked eye, it can see them because it's dim enough. How long does it take from that time you see your first alignment star to the time you get the telescope running? Well, last night, in the case of last night, it took longer than it took for Elenin to set. So, I mean, when we started, this is trees, this is your horizon. My pen is kind of running out, so I don't know how I'm going to get through this, but there's your horizon, there's Elenin at 8:43 or so. Okay, we saw our first alignment star about that same time. First alignment. So you guys aren't going to be able to read this now, so I need to do something. Alignment star, you know, at 8:40. And by the time we got the alignment done and everything going, Ellen had already gotten out. So if somebody's going to try to tell you that stuff is easy, when we're talking about this astronomy stuff, it's just not. It's just, I mean, you've got to be perfect. And with some of the equipment that's not permanent, you have to set it up. And you don't really get to start setting it up until it can spot a star in the sky, and it can't really spot a star in the sky until it's almost sunset. And then for Elenin, with Elenin so low on the horizon, 8:43 Central Time, by the time we got the telescope set up, it finally going, it was probably 9:30, so it was long gone. we did get to look at Comet Gerard, and there's some screen captures that I'll be having later, and they'll be put up with this. But a telescope can be mobile or it can be permanent. Cosmic Obsession Observatory is mobile right now because there isn't a dome built. There will be a dome built, but all this setup affects what you know, if you're going to get to see Comet Elenin with your own eyes. So everybody wants to see a certain thing. Nature and technology has its own schedule. It's going to do what it wants to do. I'm going to let's pull it down. Everything else has a second. I don't really hate to do this because I think it's important. And the essence of how I'm approaching this is okay. An opinion of mine. And I'd say every day I'm pointed to videos from friends. In order for me to keep my friends, I have to sort through 12, probably come down with a number of 6 that I'm actually going to go and look at, see the whole thing, dive in and see what I can do, because these friends are asking me to look and tell them what my opinion. Now, what happens sometimes is my opinion is actually a fact. See, this is kind of hard here, because your opinion can be your opinion and it may not necessarily be right, and it's okay for you to have that opinion, or you have an opinion that is right, and sometimes your opinion looks like, you know, you're taking a stand against whatever you're looking at, and it's not necessarily true. There's opinions. Some of them are wrong and some of them are right. Dutch's videos, I don't know what the names are. I don't even know if I should link to them. I probably shouldn't. I'm not going to link to them because, I mean, my opinion was on the last 2 of Dutch Sense's space video, as I've seen, 1 of an object with moons around it, and 2 a description of Comet Elenin with a 200,000 kilometer coma, to be wrong. My opinion is they're wrong. The fact is, they're wrong. Pointing a camera out into space, finding an object with moons, it's Jupiter. It's easily vetted. I learned that word vetted from the CNN iReports. If you go to CNN iReports and you see an article on CNN iReports, if it doesn't say CNN iReport, it hasn't been vetted. That means you and I can go put any article we want on CNN iReport. But in the case of the object that Dutch videotaped with moons around it, that object was easily vetted. The research using a free stellarium planetarium program. Put in where you are, give it a time, look where you're looking, and it'll tell you what you're looking at. So in that case, it's an object within our solar system with moons. Yes, it belongs there. It's Jupiter. The second one with the Comet Elenin 200,000 kilometer coma. I'm not going to say that some of the researchers, the scientists, I don't know if it's from NASA or not, say that the coma has a potential to become very bright. But the coma we're looking at right now is not 200,000 kilometers wide. It's not 100,000 kilometers on each side around the nucleus. The nucleus is still, in my opinion, and now this isn't a fact because I haven't measured it with a measuring stick. I have the ability probably to with my images, but I don't have the method down to do it. My opinion of the nucleus of Comet Elenin is still 4 to 16 kilometers in diameter. 4 kilometers to 16 kilometers in diameter would be the nucleus of Elenin. So that takes it from 2 to 14 miles in size. I like to think it's smaller, from 2 to 5 miles, or 4 kilometers to 8 kilometers wide. And I think the coma around the nucleus is maybe 10,000 miles radius on one side and 10,000 miles radius on the other side, so you have a 20,000 miles. I think they've taken the 200,000 kilometer coma and they put one too many zeros on it. And it's easy to do. I mean, problem is, when you add an extra zero, and if you've already done the comma, you end up with a weird number. But really, I think instead of 200,000 kilometer coma, my opinion is 20,000 radius equals 40,000 total. That's what I think. That's what I think we're working at. 20,000 on one side, 20,000 on the other side of the nucleus, 40,000 total. I mean, I still want everyone to know that when the satellite was looking at Comet Elenin, that's what you were doing. This satellite normally looks this way. They turned it to look this way. There is no sun back here that this is seen in Dutch's videos. None. Okay. So there's potential you don't see the tail either in this position because it's 7 million miles away from the satellite. Away. Sun's over here. Comet's over here. The tail's back here. And it's traveling, I would say, kind of like this, though it looks kind of different in the picture. Because it's heading in front of the sun. And Earth's over here. And there's another satellite over here. And there's another satellite in front that you can't see over here in front of Earth. If you were to look through Earth, there'd be a satellite there too. So when this thing flies within the sun, everything's going to be popping off on it. When they get this back pointed back to the sun, I mean, it's not like we're not going to see it. If they start shutting everything down, whatever, but this doesn't have 200,000 kilometer coma. I don't believe that. There's no sun back here. Easily proven. So, my opinion is, I like Dutch Sense. I like him looking at the weather. I like the radar sites that he has. I like the resources that he has for weather. I can even listen to all his theories on that, because I like them. I'll take a ride on Volcano Road. But the first two things I see, and it can be great that they're inquiries. What is that I'm seeing? Somebody help me. I'll go out, and if you have a question of what you're seeing out in space, Dutch, I'll come out and I'll give you an answer really quick. So the first two videos I saw from Dutch, I mean, credibility just went on this topic, on space. If he wants to learn, then he's going to be fine. And you'll see if you go back in my videos, I learned too. But I never, for my own sake, because I don't want to look dumb, for my own sake, I would never just drop a video out there without some type of disclaimer, or I'm learning, or potential. Now, when I first started putting out short videos, I was recording the reflection of the video camera's red light. And I said, oh, look out for Nibiru. And things have changed from there. And that was really satirical in nature if you look at it. So it's just a little different. Satire, and I can understand. But just for me personally, my opinion would be right that we're not looking at the sun as told, as Dutch said in his video, of his interpretation of the NASA clip, that the position of the comet and the satellite is such that you wouldn't see a big tail yet. So people would just, you have to recognize that this is kind of correct, that Earth has been here and the comet's been following it in. The comet has always been in a position to Earth where its tail has been pointing away as it's been coming around, and you'll see it as in the orbital path. If you were to follow Elenin's orbital path, you'll notice and the Earth is rotating too. You have to understand. So it's like we're holding a still shot. The angle of approach is like remain the same because Comet Elenin's coming one way and Earth is moving the other way. The angle of attack has actually kind of been the same. And so now we have the satellite with the same angle of attack, even more direct head-on with the sun behind it. So you're not going to see a tail there. It's not 200,000 kilometers. It's not what I believe. It's not what I see. I know Jupiter when I see it. I know comets now more than I did before. So I like weather reports from Dutch. I don't like space reports from Dutch. Y'all have a good day.